Hi everyone, welcome to video number 11 in this series on measurements. In this video we are looking at cones. In the last video we looked at pyramids, and the cone is a special kind of pyramid where the base is a circle. Just like a cylinder was a special kind of prism where the base was a circle. So when we define a cone, there are at least two numbers we should use to describe the dimensions of the cone. So the first one we should use is the radius, and that's the distance from the center of the circular base to the edge of the base. Second, there is the height, which is the vertical distance from the bottom to the top of the cone. And for our calculations, you may need to find out S. And this is called the slant height. We saw this when we looked at pyramids. And that's sort of the diagonal length from the top of the cone to the bottom of the cone along the side, on the outside. One thing that's worth saying is, as you can see from this diagram, the radius, the height, and the slant height form a right-angled triangle. So Pythagoras' theorem is going to come in handy here if I only know 2 out of 3 of these numbers. So it's common to be given R and one of either H or S, and you need to be aware of this relationship in order to make progress with a calculation involving cones. Okay, so let's write down some formulas for the total surface area and the volume. The volume is easier. So remember, the volume of a pyramid is 1/3 times the area of the base times the height. In this case, the base is a circle, so the area of the base is pi r squared, and then I need to multiply by h as well. So pi r squared is the area of the circular base. Okay, total surface area. So here there is a circle on the bottom, and then there's the curved surface going around like that. I'm not going to prove this formula, but this is the result. So the total surface area of a cone is given by pi r squared. This is the area of the base, plus pi rs, and this is the area of the curved surface. If you're curious, you're more than welcome to go online and look at the reason why the total surface area formula looks like this and why it involves the slant heights. Okay, but I'm not going to worry about it in this video. We're just going to take these two formulas and apply them in calculations. So let's do that. So here's a cone. This is actually identical to what you were given in the pretest. So it's worth saying here that r equals 5 and h equals 12. And r, h, and s are related by this right-angled triangle, and we need to know this in order to find the total surface area, which is what we'll start with. So what's the total surface area? It is pi r squared plus pi rs. Now, we weren't given s in this diagram, so we're going to have to do a calculation. So we'll do that using Pythagoras' theorem. S squared equals r squared plus h squared. So S is going to be the square root of 169, and that actually gives us 13. 5, 12, and 13 form a right-angled triangle. You might know that from previous work on Pythagoras' theorem. So now that we've got S, we can say the total surface area is pi times the radius squared, which is 5, and then pi times the radius 5 times the slant height 13. Notice we could not progress with this calculation for total surface area until we had the slant height 13. So 5 times 5 is 25, 5 times 13 is 65, 25 plus 65 gives us 90. So that's going to give us 282.74 square meters to 2 decimal places. The volume is 1/3 pi r squared times h. And that gives us 1/3 times pi times the radius squared times the height. Notice that we did not need the slant height for the volume. So if you wanted to, you could have started with the volume calculation and then found S and then found the total surface area. That would also have been fine. So now we've got to simplify this. 1/3 of 12 is 4. 4 times 25 is 100. So 314.16. I'm just going to move everything up one line. And because I've got a volume, I need to give my answer in cubic meters, or m to the power of 3. And that's it. So as long as you know these two formulas for total surface area and volume, you have everything you need to analyze cones. In some ways, I prefer this to the other kinds of pyramids because I can just take out a nice formula and apply it to every cone. I'll see you in the final video on spheres. Thanks.